Welcome back to Maths Part. Today's video, we're going to discuss transformations. Third most important topic that is translations. Okay. While doing translations, how we identify translations. First of all, the first thing that we see is that in translation, that the image, the object is always dragged. Okay. The object is always dragged or slided towards one point to another. Okay. So whenever we see a certain object that is of the same size, we always consider it as a translation because it's dragged from point A to point B. Okay. Now coming to towards how we're going to describe the translations. In translation we're going to describe the three basic things: translation vector, or matrix, or column vector. These three things are the same thing. Okay. So how we're going to describe translations? We're going to write translation by the column vector, or by the translation vector, or by the translation matrix. Okay. What vector? Column vector, translation matrix, and translation matrix, and what is translation vector. Okay. This is a very simple thing. If we say we have a coordinate of x and y, we always write in the horizontal way. But whenever we are talking about matrix or vector, we always write in the vertical way. Okay. We write it in a vertical way. Okay. For example, I have given you example over here. Okay. Okay. Now coming to us over here, we are going to describe you how translation vector works. Okay. For example, I have a vector A. Okay. Sorry. Okay. For example, we have a translation vector A. This vector A has an x coordinate and a y coordinate. Okay. If the x is in positive, we will move towards right side. Okay. But if that same vector, if that same x is in negative, we will move in the left direction. For example, I have a point over here that is considered as -1. 1 minus 1, let's consider this okay, let's consider this a simple point. And for example, I have a matrix. Matrix A is -1 and 4. That means -1 means I have to move one box towards left. If it was in plus sign, I'm gonna move one box towards right. Okay. Now coming towards the y thing. If if the column vector, or the vector has a y value, that means it is positive, we will move upwards. If it is negative, we will move downwards. That means, for example, in this example, I have +1 and 4. So that means I'm gonna move towards the right one space on the horizontal, and four spaces vertical upwards, because the y sector over here is +4. So do one, two, three, 4. So my point from here, it is back towards here. Okay. This is simplest example of the translation vectors. Okay, moving towards our second thing. If this is hard for you guys to understand, I have one more concept, that is object plus vector plus image. For example, I have an object of +1 and 4, and the column vector, let's say the column vector is -2 and 3. The image will be built as, I'm going to add this, +1 and -2 will be considered as -1, and 4 plus 3 will be 7. So this point will be considered as our image. And when I draw this image, this point on the graph, we can clearly state that the object is being dragged towards the image, so that we can identify it. And when we identify it as translation, we're gonna only write the column vector, or the vector to which it is being translated. Okay, so this is it from the translation. It's very simple. In the next video, we're gonna do some questions regarding this, so you guys would be able to understand it more clearly. Okay, we have done the translation. In the same video, we're gonna do the enlargement thing. Okay, by the word enlargement, we can clearly consider it as a zoom in or zoom out function. Okay. For example, if you can see my screen, I'm just zooming in, zooming out, and zooming in again. Okay. So what I'm technically doing is I'm doing the enlarge. I'm enlarging my screen and then I'm zooming. I'm delarging my screen. That means I am moving towards closer towards the text. Okay. So this is basically the basic concept of enlargement is that we zoom in and zoom out. Okay. If we see an image that is twice the size or thrice the size of the object, we say it is enlarged. Okay. And whenever we are describing enlargement, we are discuss two basic things. We will always mention these two basic things. The things are center of enlargement, and the other thing is scale factor. Okay. By a center of enlargement, we have always already done the rotation thing, so we know the center what the center is. Okay. In this video, I'm going to teach you how to identify the center of enlargement. Whereas scale factor, we can consider scale factor is the number of times it is getting enlarged. Okay. How many times or how many times that object is being enlarged. Okay. We can clearly state if it is given two scale factors is considered two, we will say that the image is twice the size of the object. Okay. Now coming towards over here, moving on towards the second thing, enlargement. Okay. In the previous thing we have done rotation, and in that I have discussed you two basic things that if the center is zero and if the center is not zero, the same concept applies over here. Okay. The concept says what? The enlargement, if the center of enlargement is 0, 0, we will directly multiply the scale factor with the points or the coordinates that we are given with. Okay. But if the center of the enlargement is not 0, 0, or the origin that we consider 0, 0 as a original origin, what we are going to follow the three steps that we have already done in the translation that we have already done in the rotation thing. What is that? Subtract the center, multiply the scale factor with the points, and add back to the center. For example, over here, enlargement center of enlargement is considered as. For example, the center of enlargement is considered as 2, 2. Okay. So what we're gonna do, we will take 3 points. For example, point A is, let's say, 4 and minus 2. Our point B is uh, point B is 6 and minus 4. Our point C is 4 and minus 6. Okay. What we're gonna do, we will subtract the centers. So subtracting the centers from these points. Okay, so 4 minus 2 is again 2, and minus 2 again will be considered as minus 4. Okay, same goes for the point B. 6 minus 2 will be considered as 4, whereas minus 4 and minus 2 will be considered as minus 6. Okay, coming over here, 4 plus 2, 4 minus 2 will be considered as 2 again, and minus 6 and minus 2 will be considered as minus 8. We got our points. Now these are our tentative points. We will multiply this with a scale factor. Over here, I've given you a center. Now let's consider scale factor as 2. Okay, so I'm going to multiply these points by 2. Multiplied by 2. So the first point will be considered as 4 minus 8. Second point will be considered as 8 and minus 12. 8 and minus 12. The third point will be considered as 4 and minus 16. Okay, because A2 is 16. We got our point A, B, and C. Now, coming towards the third step, that is adding back the centers, adding back the center point. So the center point is what? The center point is 2, 2. I will now add back 2, 2 in all these points. Okay, so this point would be 4 plus 2 is 6, and minus 8 plus 2 will be considered as minus 6. 8 plus 2 is 10, minus 2 and plus 2 is minus 12, and plus 2 is considered as minus 10. Okay, now 4 plus 2 is again 6, and minus 16 plus 2 is minus 14. So these are our enlarged points. Okay, these are our enlarged points. And we're going to draw it on the and these are our enlarged point, and we're going to draw it on the graph. Okay, uh, this is the basic concept of the enlargement thing. Coming towards how we want to determine the center of enlargement. Okay, so I have over here, I have two examples. Let's go for example. Okay, over here, for example, I have a small triangle and a big triangle. The small triangle, let's consider this as our object. Let's mark it as O, and the big one is image. Now, the first thing that we have identified when describing the enlargement thing is we have to find the center of enlargement. For center of enlargement, we will take any 2 points. For example, let's take point C from the board thing, the object and the image, and we connect these points to a straight line. Okay. Now take the second point. Let's take A from both sides and join these A together, and it will form a intersection at which this will be considered as our center. Okay, this is one way of doing the things. Okay, the second example, if I can, the second example is this the inverted. So whenever we have an inverted enlargement, we will consider the scale factor minus. But let's come towards the center. How we want to determine the center of enlargement. Okay, but take any 2 points. For example, let's take X. Okay, join these together, the object and the image. Now take the second point. For example, let's take Y. So connect these both image and the object Y together, and they will form a point of intersection. This point will be considered as center. This point will be considered as center. Okay. So this is the basic construction of how to determine the center of enlargement. Now coming towards the scale factor. Okay. For scale factor, we always have two formulas, that is image end and object end, or image to center distance to the object to a center distance. Okay. I'm gonna apply these in the previous example that we have done, for example, over here. Okay. We have already marked the center, so I will erase the marking. Okay. Over here, if I say the first formula was simply what? Image distance and object distance. So the object distance, if I say over here, object distance is how many? Two boxes. Sorry. The image distance is 1 and 2. And this thing, if we come towards our image thing, we want to calculate the same distance from A to B. So from A to B, I am saying 1. I'm saying 1, 2, 3, 4, 5, 6. This is 6 and this is 2. So I will apply the formula of 6 divided by 2. It will be coming as 3. So our scale factor will be considered as